This is the video lesson for Mod 3 Lesson 1, Polynomial Operations. The goal of this first lesson is we're going to be adding, subtracting, and multiplying polynomials. And so our goal here today is just going to be reviewing some of the operations that we learned from Math 2 and Math 1. So the first thing we're going to see coming up in this mod is talking about parts of a polynomial. So the first term you're going to end up seeing is talking about a lead coefficient. So when we have our polynomial in what's called descending order, which means the largest exponent is written first, and then the value or constant is written at the end. The value that's in the very front of that polynomial, in this case it would be the 5, would be considered our lead coefficient, leading coefficient. So for this first polynomial, our leading coefficient would be 5. We're also going to see a constant. So a constant, if we have it in this descending order where the largest exponent is first, the smallest one is listed last, the constant is going to be the value listed at the very end. So in this case, our constant would be -4. And finally, when we talk about terms, a polynomial is a combination of variables and values. And a lot of times we're going to see addition and subtraction signs. So all the terms here are connected with addition and subtraction signs. So for the number of terms for this polynomial, we have actually 5 terms. We're going to see in this video addition and subtraction, which we saw earlier in the year as well. So the big goal we're going to see is combining like terms. And when we're subtracting, we first want to distribute the negative sign and then combine like terms. And remember, for like terms, they have to have the same variable as well as the same degree. In this first example, we're going to be looking at adding polynomials. So you can see with this first term, we have a 3-term polynomial, which is called a trinomial. And then we have 4 terms. In this case, anything more than 4 terms, we typically call just a polynomial. So we have an addition sign here. All that means is we basically just need to remove the parentheses. And simply combine like terms. So anytime we're adding or subtracting terms, all we're going to do is find terms with the same variable and the same exponent for that variable, and just add and subtract the values in front. And the values in front, again, are called coefficients, right? So we're going to do, in this case, 8x cubed plus 4x cubed would be 12x cubed. I like to cross them out as we go. We can just go from left to right and then rewrite them in descending order if we want to. Another way is you can kind of, knowing that we have to go in descending order, we have 12x cubed. The next degree down would be, in this case, -3x squared. And that's the only x squared. From there we have 5x, and that's going to go with a -12x, so we would have -7x. And then finally, -7 and +4 would be a -3. So our first one would be 12x cubed minus 3x squared minus 7x minus 3. If the question was asking what the leading coefficient is, you would tell me it was 12. One thing we're going to also talk about is what's the degree of the polynomial. So this one is actually a degree of 3 because that's your largest exponent you see. So we didn't go over that in the first slide, but you're going to see that come up a lot when they talk about a degree. That's going to be the largest exponent that we see. For the next one, I'm actually going to skip down to number 3 and then put the answers for 2 and 4 so you could see, making sure you're getting it. For number 3, we have that we're subtracting. So really, it's like putting a 1 in front and then distributing, right? So for the first parenthesis, we have a trinomial. I'm just going to rewrite it. And then I'm going to distribute this -1. And that's going to change the sign of everything in that second parenthesis. And then now we're going to combine like terms. So again, they have to have the same variable and the same exponent. All we're doing is adding and subtracting the coefficients, or those values that are in front. And we're not adding and subtracting any exponents here, right? So 14x squared minus 12x squared is 2x squared. I'm going to cross them out. I then have 3x, which will go with 4x. So 7x. And then negative 13 minus 5 is negative 18. So this, our final answer would be 2x squared plus 7x minus 18. So it's in descending order. If the question asked what was the leading coefficient, our leading coefficient would be 2. That's the number in front. And then if it asks for the degree of the coefficient, the degree of the polynomial, that's the largest exponent we see, and the degree would be 2. For the remaining two problems, those ones they're the same thing, but I'm going to write the answer so you could see, if you try them, you could see if you get the correct answer. Number 2 should be negative x minus 10. And for number 4, you should have x cubed minus 2x squared plus x minus 4. So those would be your answer for 2 and 4, if you'd like to try those out and making sure you're getting the correct answer. For example 2, this is where we start talking about multiplication. So multiplication is where we add the exponents. Addition and subtraction is where we just add and subtract the coefficients, or those numbers in front. So for this, we're going to again see when we distribute. So if I do 9 times 4, I'm going to get 36. And then I'm adding those exponents out. So this would be x to the third. We're then going to do 9 times negative 7, so that's negative 63. I have a little 1 here. And then x times x would be x to the second. And then finally, 9 times 3 is 27. And then I still have an x. So this would be my final answer. Again, if the question had asked what's the leading coefficient, you would tell me 36. If the question said what is the degree, you would tell me 3, because that's your biggest exponent. For number 2, again, same thing. You're going to distribute this 8x cubed. Wherever you don't see an exponent with the x, you can write a little 1 there. And again, we're just multiplying the values, or those coefficients, and then adding the exponents, because we're doing multiplication. So 8 times negative 5 is negative 40. X to the 1 plus 3, which is 4. 8 times negative 3 is negative 24. And then x to the third. And then finally, 8 times 7 is 56. And x to the fifth. I want to write my answer in descending order, because that's usually just how we work with this. So x to the fifth is the biggest exponent. It has to be written first. Then minus 40, x to the fourth, minus 24x cubed. So if the question was asking what is our leading coefficient, you would tell me 56. If the question said what is the degree of this polynomial, like what's the degree, that would be your largest exponent, which is 5. The last part we're going to see with this video is multiplying polynomials. Typically we learn this, you maybe learned this last year, it's called FOIL. We usually don't like to use the term FOIL all the time, because that doesn't work when it's something that's a trinomial or something more than 3 terms. We're going to still use what's called, FOIL, but really that's really multiplying, right? FOIL is really multiplying polynomials. So we're multiplying and then simplifying. So FOIL is a good strategy for like these problems here, but just keep in mind what you're actually doing. The operation is multiplication, and we're simplifying, because the examples we're going to see after these 3 are not going to work with FOIL, because there's more than just 2 terms in the parentheses. So just keep that in mind. It's very similar to Math 2. We just usually don't use FOIL when we're talking about multiplying as much, because it doesn't work for the later problems we're going to see, because there's more than just 2 terms. So what we're going to do is we're simply just going to distribute. So I'm going to take this 3x and multiply everything in that second parenthesis. And the reason is because I'm multiplying these two binomials here. So I'm going to distribute 3x to 2x. Remembering, these are little x to the 1, so we're going to add those exponents. And we end up with 6x to the second. And then I'm going to distribute a 3x to the 7. So 3 times 7 is 21. We got 21x. And then now I'm going to take this 1 and distribute it to everything in that second parenthesis. So 1 times 2 is 2, so 2x. 1 times 7 is 7. So I'm really just multiplying those two binomials, and then we're going to put our like terms together, 21x and 2x. So 6x squared plus 23x plus 7. And if I had asked what the leading coefficient was, you would tell me 6. If I asked what the degree was, you would have told me 2, right? Because that's your biggest exponent and your value in front when it's in descending order. Question 2 and 3 are very, very similar. So you're really just distributing, making sure that when you're multiplying like bases, you're adding the exponents. So this first one would be 16x to the third minus 8x squared minus 14x. Then negative times a negative is a positive 7. We can't simplify any further, so this would be my final answer. And then number 3, same thing. We would just distribute, and you get x squared minus 8x plus 8x, and then minus 64. And then these do have like terms that cancel out, and we would get x squared minus 64. These last two examples are the same thing, except instead of having two binomials, we're going to have a binomial, which is 2 terms, and a trinomial, which is 3 terms. So we're going to do the same exact thing. So I'm first going to multiply everything in the second parenthesis by 3x, remembering that if we multiply like bases, we have to add their exponents. So we're going to get, in this case, let me erase that. For this one, we're going to get 3x to the third minus 6x squared, and then plus 12x. Okay, and then now I'm going to distribute underneath with my 1. You're going to find there's going to be a lot of terms, so it starts to get kind of long. What I recommend is that, once we write this those first 3 terms that I have in green, and I start distributing a new number, you can actually just write it right underneath and just make sure the like terms maybe are lined up. So in this case, I have 1 times x squared is x squared. Maybe I'll write it under here. 1 times negative 2 is negative 2x. 1 times 4 is 4. And now when I put my like terms together, it's kind of like I can just add them straight down now. This is just like one of a whole bunch of ways. You don't have to do that, but it makes it easier so it's not taking up as much room. So if I add this straight down, I get 3x to the third. This is negative 6 plus 1, so negative 5x squared. 12x plus negative 2 is 10x. And then the 4 doesn't combine with anything. So this would be my final answer. And again, you get the same thing if you wrote it as one long line. It just sometimes saves a little bit of space, and it's easier when you have them all lined up. Same idea with question number 5. So I'm going to start with this first trinomial. I'm going to distribute to everything in the second parenthesis. And so remembering to add the exponents if I'm multiplying. So 3 times 2 is 6. So 6x to the fourth. 3x squared times 3x is 9x to the third. And then 3x squared minus 1 is negative 3x squared. We're now going to move to the next term, which is a 1x. So we're going to distribute to everything in here. So x times 2x squared is going to be, so 1 times 2 is going to be a 2, and then x to the third. So I might line it up underneath this x to the third that I already have. 1 times 3x is 3x squared. 1 times x times negative 1 is negative x. And then the last one, we're going to distribute this minus 7. So negative 2 times 2x squared is negative 14x squared. Negative 7 times 3 is negative 21x. And negative 7 times negative 1 is negative 7. And then finally, we can just add all this straight down. So we get 6x to the fourth. 9 plus 2 is 11x to the third. Negative 3 plus 3x is 0. This cancels out. Minus 14x squared. Negative 1x plus negative 21 is negative 22x. And then minus 7. So this would be our final answer right here. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.